We are taking this from the Northern Cape, September 2015, question 8. In the circuit diagram below, the EMF of the battery is 6 volts and its internal resistance is 0.10 ohms. The resistance R is unknown. This is the positive, this is the negative. The total current will flow in this direction. Since the 4 ohm and R are connected in series, we'll have the total current flowing through the both of them. Total current there, and then the current will go inside of the battery. 8.1. Explain the term internal resistance. So this is the resistance that opposes the flow of charge within the battery. 8.2. Write down an equation for the terminal potential difference using the values given. The EMF is equals to V external, and here I'm going to use I multiplied by R because I do have the internal resistance. So V external should be equals to the EMF, which is 6 minus I, and then the internal resistance is 0.10. 8.3. Draw a sketch graph of the terminal potential difference versus current. Indicate the following in the diagram: the value of the EMF and then the current at which the terminal potential difference is 0. So we have the potential difference measured in volts and then the current measured in amperes. The value of the EMF is measured or is registered on the voltmeter when the current is 0. So that will be 6. That will be the value of the EMF. And then the graph will look like that. So now we need to find what the current is going to be when the potential difference is 0. So we'll just say 0 is equals to 6 minus I 0.10. The current should there be 6 divided by 0.10. So this is 60 amps. So that must be a 60. So this is the EMF and that's the current. 8.4. The energy dissipated in the 4 ohm resistor is 40 joules. So this is 40 joules. And the energy dissipated in the resistance R is 60 joules. 60 joules. Energy refers to the work. Okay. 8.4.1. We need to calculate the resistance R. Okay. So W is equals to I squared multiplied by R times the time. So the thing that is common there is the current. So I'm going to make current the subject of the formula. So this is going to be I squared is equals to W over R delta T. So the current that flows through the 4 ohm will be equals to the current that flows in R. So this should be equals to W for the 4 ohm over R4 ohm multiplied by the time. Then the W through R all over RT. So the T's are going to cancel out. And then the work there is 40 over 4. And then the work there is 60 all over R. Therefore, R should be equal to 60 times 4 divided by 40. So I'm getting 6.0 ohms, 8.4.2. They want the total current in the circuit. EMF is equals to I R plus R. The 4 ohm and then R are connected in series, so I'm going to add the two to get R series. So that was going to be 10 ohms, which is the R external. The EMF is 6 volts. The current, that's what I'm searching for, that's a 10, then 0.10. So the total current should be I'm getting 0.59 amps, 8.4.3. They want the reading on the voltmeter. So V external is equals to I total multiplied by the resistance. The total current is 0.59 and the total resistance is 10. 0.59 times 10, I'm getting 5.9 volts. So we can even say the EMF should be equals to V external plus I times the current. The EMF is 6. V external is what we are looking for. The current is 0.59 multiplied by 0.10. So V external should be equals to I'm getting 5.94 volts. 8.5. A 7 ohm resistor is now connected in parallel to the 4 ohm resistor. So we are connecting a 7 ohm resistor there. How will this action affect the reading on the voltmeter? Write down increases, decreases, or remains the same, and then briefly explain the answer. So the first thing we are going to look at is the external resistance. When you connect a resistor to a parallel combination, so whenever we are forming a parallel combination, R external will decrease. So R external decreases, and then the current increases. From the EMF is equals to V external plus I times R. The EMF doesn't change and the internal resistance doesn't change. So when the current increases, it means that the V lost goes up, and then V external is obliged to go down. So this means that the reading on the voltmeter decreases.